Alright, you guys, today we are going to start off with a few warm-ups. If you look at your note packet on page 4, number 6, I want you to try number 6. I also want you to try on page 6, number 11, A and B, and then 12 and 13 as your warm-up. So again, that is page 4, number 6, page 6, 11A, B, and then 12 and 13. Okay, I'll give you a few minutes, 2 minutes, 2 or 3 minutes to work on those, and then we'll circle back before we start 4.2. Okay, hopefully, if we look at number 6 on page 4, okay, you are a vice president and would like to show that the current salaries are reasonable. Which measure of center, so central tendency, would you use as the average salary to justify your claim? So typically when we're looking at this, we're going to use either the mean or the median. Okay, in this case, we're going to use the mean because those $300,000 salaries will make the average look better and higher. Okay, that they're reasonable. However, if you are a union rep for your department and maintain that pay raise is in order, like you want that a raise, you're going to use the median because it will be reflective of everyone's salary. So the question is, should you get a raise? Absolutely, if you use the median. Okay, and then if we turn to number 11, and I only chose A and B for right now. Mrs. Smith gave an assignment worth 5 points for a period 1 class that has 25 students in it. The results are shown. Now, we don't know how many students at the time, we didn't know how many students scored a 4, so we need to figure it out. We know there's 25 kids in total, so we're adding up 1 plus 4 plus 8 plus x, because we don't know, plus 7. In the end, when we end up solving for x, 5 students received a 4. Now, what is the class average? Well, 1 student got a 1, 4 students got a 2, 8 students earned a 3, 5 students earned a 4, 7 students earned a 5. So you set up, as you're taking the average, add those scores together and divide by 25, and your average is 3.52. Okay, now if we move to 12, if x is the median of 7 numbers listed below, which of the following could be the value of x? Well, if you put them in order, okay, if you put them in order from least to greatest, as you see on the board, you need to find x. So the median is that middle number. So it has to be between 11 and 14. It can't be 5 because that's less than that. Can't be 8 or 9. So the best one that would fit is 14. Okay. Now the mean score of 8 players in a basketball game was 14.5 points. If the highest individual score was removed, the mean score of the remaining 7 players becomes 12. What was the highest score? So what we do is we multiply the mean score of 8 players was 14.5. So we multiply those together and get a total of 116. Then the highest individual score removed the mean score, so we have to find the difference. So we take 12 points times 7 players and get 84. Then we subtract 116 from 84 to get 32, which is the correct answer. Okay, so you should have went through when you pause the video to answer these at the start, okay, for Edpuzzle and answer. All right, so now we are getting into 4.2, which is the normal curve and the spread, okay? So a normal curve is a smooth curve that is symmetric and bell-shaped. data distributions that are a mound shaped are often modeled using a normal curve. We say that such a distribution is approximately normal. So this diagram here is what a normal curve looks like, okay? The mean, median, and mode would approximately be in the middle, okay? So when you have a normal distribution, okay, or when you're finding it out, the mean, median, and mode would typically be in the middle. But what always starts off your normal curve? We typically use the mean, okay? The two sides end up being symmetrical. So if we were to split this in half, we would have the same thing on either side. Okay, those are the tails. So how it fans out is your tail. Okay, the data starts to flatten out. Later in this unit, we will see when a curve is not normal. Okay, so one more quality of dispersion, okay, looking at the spread, it's called standard deviation. Okay, this notation should look familiar because we saw that in our calculator when we calculated mean, range, median the other day. Okay, so SX is standard deviation, which stands for sample standard deviation, because a lot of the data we're going to look at are samples. Okay, so the standard deviation is the measurement statisticians use for the amount of variability or spread. Okay. As the term implies, the standard deviation is a standard or typical amount of deviation or difference from the mean. Okay, so the standard deviation in a very rough terms is the average distance from the mean. Okay, and that's a very loose statement because standard deviation, basically you need to know how spread out the data is. Okay, the larger the standard deviation, the further you are from the mean. So if we had a standard deviation of, say, test scores, and our standard deviation was 13, that means the scores were kind of all over the place and we have some outliers, making the scores, there's a lot of variability, okay? If we had a standard deviation of 3, then all the scores were roughly the same around the average. Okay, we're going to use our calculators at some point to find standard deviation using the one-var statistics. Okay, interpreting the mean and standard deviation, we use this all the time. Okay, however, the mean and standard deviation we use mainly when we have a normal curve. Okay, and this part here we could just cross out because we do not need that. Okay, and if you turn to the next page, this is what small standard deviation and large standard deviation looks like. So small standard deviation, it's very close to the average. So when we're talking about test scores, we want small standard deviation because you're around the average. You meet the expectation, okay? Large standard deviation means the data is very spread out, okay? So how we create a normal curve? Well, first and foremost, you want to identify the mean, okay? So if we look at example 1, the mean is, the average is 82, okay? So when you graph, you draw a line in the middle, and that's where your mean will go, okay? Then when we incorporate the standard deviation, okay, the standard deviation here is 5. So one standard deviation away, okay, so one standard deviation away means you are adding 5 to the mean, okay, so 82 plus 5 is 87, and you're also subtracting 5 from the mean to get 77. So one standard deviation away, that range is from 77 to 87. Okay, Then if we look 2 standard deviations away, which is here, you are adding another 5. So we would take 2 standard deviations. Okay, we would do 87 plus 5 to get 92, 77 minus 5 to get 72. So 2 standard deviations away would be a range of 72 to 92, which is about 95% of our data. Okay, then if we go 3 standard deviations away, and this is the most you would go. So 3 standard deviations is the most you would see. Okay, 3 standard deviations away, you would take 72 minus 5 to get 67, and 92 plus 5 to get 97. Okay, so 2 standard deviations away is between 67 and 97. So if we were to break these down in percentages, okay, 68% of the data that you are recording, so this is 68%, is between 77 and 87. So 68% of all the test scores you have are between 77 and 87. Then it gets larger, 2 standard deviations away would be 95%. Okay, so 95% of the test scores that you have logged are between 72 and 92. Then last but not least, 99.7%, which is pretty much the majority of your data, is between 67 and 97. Okay, so a normal curve, all the percentages will equal 100% because you also have some scores that fell below, which is 67, or above 97. Okay, so no matter what, you have 3 standard deviations from the mean, above and below. Okay, so using number 1 as an example, I want you to fill out the normal curve in number 2. Go ahead, pause the video and give it a try. Okay, so we should have got the scores on the final exam in Ms. Parker's Algebra 2 classes. Had a mean of 88, so that goes right there in the middle, okay, and a standard deviation of 3. So standard deviation is on the smaller side, so that means the majority of her data is very close. There's not a lot of variability. So 1 standard deviation away is 85 to 91. 2 standard deviations away is 82 to 94. Then 3 standard deviations away is 79 to 97. Okay, so that's how you would fill out a normal curve. Okay, we will be getting into very shortly what it would look like. How can we tell which data is closely related as opposed to others? Okay, based off the standard deviation. All right, so if we look at some of the steps, okay, steps to find. So you want to label the mean, okay, or find the mean, label or find the mean, okay. Then add the standard deviation to the mean 3 times. Okay, so this means it's above the mean, okay, and then subtract. So this means it's below. Okay, so we are going to use our calculators. I'm going to show you a few of these. Okay, all right, so now we're going to round to the nearest hundredth. So in our calculator, Okay. Go to our calculator, and we want to enter, go to Stat, and Edit. Remember, if you have anything in your list, you want to highlight L1, then clear, then enter to start fresh. So I'm going to enter in 1, then 3, then 5, then 14, yep, then 17. Okay, I'm entering my data set 1, or data set A in this case. And now I'm going to go to Stat, Calc, 1 variable statistics, hit enter, and calculate, and it says here round to the nearest hundredth. So X bar, remember, is 8, and SX is our standard deviation, and we're going to round to the hundredths place. So we have our average for data set A is 8, and our standard deviation is 7.07. So we see a little variability in the data just looking at it. So now we're going to see, and I want you to take a guess. All right, looking at data set B, do you think the standard deviation is going to be greater, the same, or smaller? Okay, pause the video and put your answer in there. Okay, let's check it out. All right, we're going to check this out. We're going to clear our list, Stat Edit, highlight, clear. All right, so we have 5, 6, 8, 9, 12. Okay, then Stat Calc, 1 variable statistics, enter. Okay, our average is still the same, it's 8, but now our standard deviation is 2.74. Okay, 2.74. So we have mean of 8, standard deviation of 2.74, which is definitely lower than our first one. Okay, so now looking at data set C, you have all of the same numbers, so the mean should be very easy to figure out, which is 8. Okay, is there any variability? So I want you to take a guess. What do you think the standard deviation would be? Okay. Go ahead and check it out in your calculator. Okay, if you received a standard deviation of 0, you are correct. There's no variability there. Okay, so interpreting the standard deviation. Okay, data set A, largest standard deviation and the largest range. Data set B, the data is really close together, so there's not a lot of variability. Data set C, there's no change, it's all the same. So there's no different numbers there, therefore there's no spread. Okay, so what I want you to do is these next 2 examples, okay, and describe. Find the mean and standard deviation of each data set. Round answers to the nearest 10th if necessary. Okay, so you're going to try examples 1 and 2. Okay, so hopefully for the 2 examples, the speed in miles per hour of Will's last 6 pitches, okay, an average was 75 and the standard deviation was 3.5. So looking at it, what conclusions have you made? Well, some can say there's a small standard deviation because there's not a lot of variability. However, number 2, Nora's science grades, the average was 84. However, the standard deviation was 15.5. That's because there is an outlier of 52, causing the spread to be very large. Okay, and there's some variability there, but looking at that outlier, it also drags out the standard deviation of how spread out the data is. Okay, so more visual representations of data is called a histogram. That's one of them. Okay, it's a graphical representation of a frequency distribution of data within equal intervals. So luckily you will not have to create a histogram, but you you need to interpret it. Okay, so we have distribution of math test scores. Number of students is your y-axis, and your test scores is your x. Okay, so how many students scored between 91 and 100? So you come here, and it looks like we have 2 students. 81 to 90 was 8. 71 to 80 was 12. 61 to 70 was 10. 51-60 was 5. 41 to 50 was 3, making a total of 40 students. So we just filled out, we went from a histogram to a frequency table. That's what we just filled out. Okay, so now total the frequency column to determine how many students took the math test. So we did both of those. How many students got between 61 and 90? Okay, so 61 and 90. So we're looking at between 61 and 90. We will add up those students. So 8 or 81 to 90, 12, 71 to 80, and 61 to 70, there was 10 students, making a total of 30 that scored between 61 to 90. How many students got between, oops, I wrote that in the wrong spot, okay? How many students got lower than a 61? So now we look at lower than 61 is 41 to 50 and 51 to 60, which would be a total of 8 students. Okay. Now a question for you guys. Can you tell how many students got a 76? Okay. Hopefully you realize you can't, because the histogram is given in ranges, not a specific student score. So we could tell how many students got between a 71 and 80, which was 12 students, but we can't specifically pinpoint, based off this chart, how many people or how many students got an exact 76. We do not know that based off a histogram and a frequency table. Okay, so we need to analyze the shape. Okay, the mean and median fall within the middle. Okay, it's symmetric left and right. So this is a picture of a normal histogram. Okay, however, there's 2 types that we might see. Okay, skewed right, where you have the tail of the data flowing to the right, which means the mean is greater than the median. Okay, on the flip side, skewed to the left is where the tail is longer to the left. So the mean is less than the median. Okay, so one of the biggest misconceptions that I see is people look at where the majority of the data lies to determine if it's skewed right or left. That is false. You want to look to see where the tail flattens out. Okay, so that's why skewed right, looking at the graph, it kind of fizzles to the right, creating a longer tail to the right. Skewed left, longer tail to the left. Okay, so looking at this first histogram, and I'm sorry that it's hard to see, okay, we want to determine if this graph is skewed left, skewed right, or symmetrical. Okay, and explain the relationship between the mean and median. Pause the video and try this out. Okay, so the graph, hopefully you're finding out that it kind of drags out to the right. So this is skewed right. It's skewed right, meaning the mean is larger or greater than the median. Okay, So now, using your notes about symmetric and non-symmetric histograms, determine if the histograms represent a graph that is symmetrical, skewed left, or skewed right. Then determine the difference between mean and median. So go ahead and pause the video. Okay, so we should have seen that A was skewed right, meaning, just like above, the mean is greater than the median. Okay, the middle graph is symmetric, meaning the mean is equal to the median. Okay, and then skewed left is the mean is less than the median. Okay, another visual representation of a graph is called a dot plot. Okay, it's a dot plot. It's dots pretty much like a frequency table, but it's not ranges. So for example, minutes to eat breakfast. If we look at 3 minutes, there were 5 people, counting the dots above, there were 5 people that take 3 minutes to eat breakfast. Okay, so that's what a dot plot looks like. Okay, what is the most frequent amount of time people ate breakfast? So you're looking for the majority of dots. So looking at this, most frequent, okay, which also would be the mode, is 10 minutes. Okay, what is the range in times for people to eat breakfast? Well, the longest was 12 minutes minus 0, meaning those many people did not eat breakfast. So the range of times 12 minus 0 is 12 minutes. Okay, how many people took 8 minutes to eat breakfast? So you go to 8 and see how many dots there are, and there's 2 people. Okay, so dot plots have the same general conclusions as histograms. So you could see how they look very similar to histograms. If they are symmetric, okay, the mean and median are approximately equal and the same in that first example. And then you have 2 examples that show when it's skewed right and when it's skewed left. Okay. And the last visual representation was one that could be most common that we could do percentages for. Okay, it's a box and whisker plot, or also called a box plot. A display of data that separates the data into 4 even parts. Not necessarily even to the eye, but there's 4 sections. Okay, each part of the graph represents a quarter, so 25% of the data. The graph is placed above or below or next to a number line. Typically, we're going to do these graphs above. Okay, so some vocabulary to consider, and I'll go through what it shows up above where the graph is. The lower extreme is your min. So where I'm placing that dot, this is your minimum. Okay. First quartile. So it also looks like this. Quartile 1 is the median of the lower half. So there is 25% of data below quartile 1. Okay, so quartile 1 is this first line here, is quartile 1. So from here to here, so min to quartile 1 is 25%. Okay, then you have the median, which is also called the second quartile, but we're looking at the median. It's the middle number, and that's also 25%. So 25% from quartile 1 to the median, which is this line here, that's also another 25%. Okay. And the third quartile is from the median to the upper half, and that's this next line here, which is another 25% of the data. Okay. And last but not least, we have our maximum, which is 25%. Okay, so if you look at the median and to the left, quartile 1 and the min represent 50% of the data. Okay, same with quartile 3, and the max is 50%. All right, there's something called the interquartile range, which is the middle 50%. We use the interquartile range, which is quartile 3 minus quartile 1, when there is an outlier. Okay, when there's extreme outliers, you're going to use the median and the interquartile range. If there's normal data, you would use the mean and standard deviation. It's more accurate. Okay, so we're going to enter these guys into our calculator. We actually saw this when we were looking at the median. It's called the 5-number summary, which is the minimum, quartile 1, the median, quartile 3, and the max. Okay, so we're going to do the same thing in our calculator. Okay, so go to your calculator, stat, edit, and remember to clear out, L1, clear, enter, and we're going to enter the data below. So for the number of calories in each sandwich. So 320, oops, my 2's not working, 320, 420, 580, 270, 320, 380, 360, 270, 440, and 470. Okay, so we should have 12 there. So we're going to go to stat, 1 over to calculate, 1 var stats, go down to calculate. Okay, this is our mean, but we're not really looking at that right now, which is 371.7, okay? And our standard deviation is 91.8. So that's a pretty large standard deviation because there are outliers, okay? So since there's a lot of outliers, we're going to look at something called our 5-number summary, which is in this ballpark here. There's the 5 numbers. Your minimum is 270. Your quartile 1 is 315. Your median is 340. Quartile 3 is 430. And the max is 580. So I'm going to jot those down. That's your 5-number summary. Anytime it asks to create a box and whisker, you need that 5-number summary. Okay? So we have 270 as our minimum, and I'm just copying it over from our calculator. There obviously is a way to find this by hand, but that's not necessary. We're going to use our calculator for it. Okay? So now that we have our 5-number summary, we have to create a graph. And here's our line graph. Okay? You could do increments, whatever you choose to do, looking at your data. Okay? I'm going to skip one. I'm going to start at 250 and then skip everyone 25. 325, 375. And you guys will be able to see this better on the notes that are posted. Okay, so we know the minimum is 270, so it's roughly in this ballpark. I'm going to put a dot. Sometimes you'll see a line there. I'm going to put a dot. 315 is the first quartile, so it's roughly here, and that's with a line. Okay, then we have 340, which is pretty close to it. And again, my lovely smartboard is a little off, but bear with me. And then our upper quartile, which is quartile 3, is 430. And then our maximum is 580, which is here. So now we connect. We have 1 whisker, we have our box, and our other whisker. Okay, So this is what our box and whisker looks like. All right. So I want you guys to try this. All right. So pause the video and try number 4. Okay. So hopefully you should have gotten this 5-number summary. Your minimum is 63. Quartile 1 was 71. Your median was 74. Your upper quartile or quartile 3 was 79. And your maximum was 84. Okay. And this is what your box and whisker would look like. Some of you might have a different scale, so it might look a little bit different, but that's the general idea. Okay. So now, what I want you to do is look at our box and whisker here, all right? And I want you to try to answer these questions, all right? And again, everything is going to be an approximation because the scales are a little hard to see and it says approximate, okay? So you're looking for the approximation. So now we will analyze box plots. We'll actually go through this together, okay? Angela is the first one. Carl is the second one. So what is the approximate median of Angela's sales? So the median, remember, is this middle line here. So we could roughly say it's approximately 28, okay? What is the approximate maximum of Carl's sales? So the maximum is here. So we could approximately say 62, okay? Which salesperson has a smaller median? Well, we know Angela's is 28. Carl's is approximately like 32. So Angela has the smaller median. Okay, so now we want to determine true or false. 25% of Carl's sales were between approximately 15,000 and 32,000. Okay, so 25% of Carl's sales. If his median is approximately 32 and let's say his quartile 1 is about 15, this is 25% of the data. So that is true. Okay. True or false? 75% of Angela's sales were between approximately, and if you notice everything's approximately, 18,000 and 58,000. Okay. So 18,000 is here. Let's do another color so you can see. So 18,000 is quartile 1, okay? And 58,000 is our maximum. So quartile 1 to the median is 25. The median to quartile 3 is 25. Quartile 3 to the max is 25. When I add those all together, I do end up with 75%, which is true. Okay? And here's all the distribution of box plots. Okay? So it's symmetric when you have the line in the middle, even on either side. Okay? If it's skewed right, if you notice, you always look from the median. If it's a longer stretch, that means it's skewed right. If the median, again, is in the middle and a longer leg or whisker to the left, then it's skewed left. Okay? So now I want you to try this. Some of the numbers are a little off, so I just want to show you. The minimum was 38. Quartile 1 was 72. The median was 88. Quartile 3 was 96. And the max is 102. So what I want you to do is try examples or questions 1 through 9. They're two separate questions. Okay, so 1 through 5 is regarding test scores. 6 through 9, and I'll go through this. This is 0, 20, 48, 60, and then 190. Okay, I want you to interpret these box and whiskers 1 through 9 and check your answers on Google Classroom, okay, for a full key. Then I will give you the practice. Okay, but we went through a lot just now, all right? However, it's all roughly the same looking at different distributions, all right? We will definitely go over this, all right? And I will post another video later on after class for more explanation if needed, all right? But we will definitely look again at this on Monday.